Hello all. We will be starting with page number 65, problem 3, part C. Solve sin z is equal to 5. And so from the definition of complex sine function, that is sin z is equal to e raised to iz minus e raised to minus iz divided by 2i. In this question given sin z is equal to 5, which implies e raised to iz minus e raised to minus iz divided by 2i is equal to 5. Then e raised to iz minus e raised to minus iz is equal to 10i. Multiplying both sides by e raised to iz and rearranging, we get e raised to minus e raised to I 2z minus 10i into e raised to iz minus 1 is equal to 0, which is a quadratic in e raised to iz. Using quadratic formula, e raised to iz is equal to 10i plus or minus root of 100 minus 4 divided by 2 is equal to 10i plus or minus I into root 96 divided by 2. After simplifying, we get 5i plus or minus 2 root 6 into I is equal to, taking I outside, 5 plus 2 root 6 all into I. Since 5 plus or minus 2 root 6 into I is a purely imaginary number and 5 plus 2 root 6 greater than 0. Then Iz is equal to log of 5 plus or minus 2 root 6 into I is equal to log of exponential log of 5 plus or minus 2 root 6 plus I into pi by 2 plus 2 and pi, where n is equal to 0 plus or minus 1 plus or minus 2 etc. Then taking I to the right side, z is equal to 1 by I into log of 5 plus or minus 2 root 6 plus I into pi by 2 plus 2 and pi, which is equal to 4n plus 1 into pi by 2 minus I into log of 5 plus or minus 2 root 6. Since the part of log, that is minus log of 5 minus 2 root 6 is equal to log of 1 by 5 minus 2 root 6 is equal to log of 5 plus 2 root 6 by 25 minus 24. Here we multiplying both the denominator and numerator by the conjugate of 5 minus 2 root 6, that is 5 plus 2 root 6, and then which is equal to log of 5 plus 2 root 6 by 25 minus 24 is equal to log of 5 plus 2 root 6. Then as z become, z is equal to 4n plus 1 by pi by 2 plus or minus I log of 5 plus 2 root 6, where n is equal to 0 plus or minus 1 plus or minus 2 etc. Then next, complex hyperbolic functions. The complex hyperbolic sine and hyperbolic cosine functions are defined by sin hz is equal to e raised to z minus e raised to minus z by 2, cos hz is equal to e raised to z plus e raised to minus z divided by z 2. Then tan hz is equal to sin hz by cos hz, cot hz is equal to cos hz by sin hz, sec hz is equal to 1 by cos hz, cosec hz is equal to 1 by sin hz. Next is the relationship between complex hyperbolic and trigonometric functions. From the above definition of sin hz and cos hz, replacing z by iz, we get sin h of iz is equal to e raised to iz minus e raised to I minus iz divided by 2 is equal to, taking I outside, I into e raised to iz minus e raised to minus iz divided by 2i is equal to I into sin z, or sin z is equal to minus I sin h of iz. And cos h of iz is equal to e raised to iz plus e raised to minus iz divided by 2, which is equal to cos z, or cos z is equal to cos h of iz. In this similar manner, if we substitute iz for z in the expression for sin z and cos z, we get sin of iz is equal to e raised to I into iz minus e raised to minus I of iz divided by 2I is equal to e raised to minus z minus e raised to z divided by 2I is equal to minus 1 by I into e raised to z minus e raised to minus z divided by 2 is equal to I into sin hz, or sin hz is equal to minus I sin of iz, and cos iz is equal to e raised to I into iz plus e raised to minus I into e raised to minus I into iz divided by 2 is equal to e raised to minus z plus e raised to z by 2, which is equal to cos hz, or cos hz is equal to cos of my iz. Then thus we obtain the relationship between complex hyperbolic and trigonometric functions. Sin z is equal to minus I sin h of iz, and cos z is equal to cos h of iz. Sin z is equal to minus I sin of iz, and cos h z is equal to cos of iz, which implies tan iz is equal to sin iz by cos iz, which is equal to I into sin hz by cos hz is equal to I tan hz. The identities which should have to be studied. First one, sin h of minus z is equal to minus sin hz. Second one, cos h of minus z is equal to cos hz. Cos h square z minus sin h square z is equal to 1. Next, sin h of z1 plus z2 is equal to sin h z1 plus sin h z1 cos h z2 plus cos h z1 sin h z2. Next, cos h of z1 plus z2 is equal to cos h z1 cos h z2 plus sin h z1 into sin h z2. There is a mistake. That's all. Thank you.